dear children, welcome to today's class. Today we are going to discuss some questions from probability. First question, what is the range in which the probability of an event of a random experiment lies? What is the range in which probability of an event of a random experiment lies? Okay. Probability, the maximum value of probability P of E, the maximum value that is 1 and the minimum value that is 0. Okay, so the probability of an event is always lies in between 0 and 1. Now second question, a die is thrown once. What is the probability of getting a perfect square composite number? A die is thrown once. What is the probability of getting a perfect square composite number? Perfect square composite number we need to get. So the possible outcomes of die throwing experiment, that is 1, 2, 3, 4, 5, 6. Okay, this is our possible outcomes. So total we have 6 outcomes. Total we have 6 outcomes. Okay, total we have 6 outcomes. So the number of elements in sample space, that is equal to 6. And here we need to get a perfect square composite number. Perfect square composite number. We have only one perfect square composite number, that is 4. So the favorable outcomes, the number of favorable outcomes, that is 1. The total number of outcomes 6. So the probability of getting a perfect square composite number, that is 1 by 6. Now third question, a die is thrown once. Find the probability of getting an even composite number. Die thrown once. Find the probability of getting an even composite number. Even, we need to get even composite number. Even numbers 2, 4, 6. 2 is a prime number, so we can't consider this. Then the favorable outcomes we have 2, that is 4 and 6. The even composite numbers, that is 4 and 6. So we have 2 outcomes. Then the probability here it is 2 by 6. Probability here it is 2 by 6 because the total number of outcomes is 6 and the even composite numbers, number of even composite number is 2. So the probability is 2 by 6 or this is 1 by 3. Next question. A number is chosen at random from the numbers. A number is chosen at random from the numbers. -3, -2, -1, 0, 1, 2, 3. What will be the probability that square of this number is less than or equal to 1? Okay, square of this number is less than or equal to 1. So we need to find out the numbers which gives the square of that numbers is less than or equal to 1. Okay, -3 square 9, that is not less than or equal to 1. Plus 3 also excluded. -2 square 4, that is not less than or equal to 1. So -2 and plus 2 is excluded. -1 square, that is 1. Less than or equal to we have, so we can take -1. So plus 1 is also possible. Now 0 square is 0. So total, the favorable outcomes, that is equal to 3. The favorable outcomes, that is equal to 3. And the total number of outcomes, 3, 4, 5, 6, 7. Okay, total number of outcomes, that is equal to 7. So 3 by 7 is the probability of getting a number less than or getting a number that the square of that number is less than or equal to 1. Next question, what is the probability of occurrence of an event that is sure to happen? What is the probability of occurrence of an event that is sure to happen? Sure to happen means that is a sure event, and the probability of sure event, that is 1. The probability of sure event is always 1 and the probability of impossible event, that is always 0. The probability of sure event is 1 and the probability of impossible event, that is 0. Next question. A die is thrown once. Find the probability of getting a number which has at least 2 factors. A die is thrown once. So the outcomes 1, 2, 3, 4, 5, 6. Okay, this is our outcomes in the case of die throwing experiment. And we need to get a number which has at least 2 factors. Which has at least 2 factors. Okay, here we will consider and the numbers having at least 2 factors. 2. Okay. 1 and 2 factors. 3. 1 and 3 factors. 4. 1, 2, 4 factors. 5. 1 and 5. 6. 1, 2, 3, 6. Okay. So for the numbers 2, 3, 4 and 2, 3, 4, 5 and 6, we have at least 2 factors. We have at least 2 factors. Except this one, all other numbers have at least 2 factors. So the favorable outcomes, that is 5, and the total number of outcomes 6. Favorable outcomes, that is 5, and the total number of outcomes 6. So the probability of getting at least 2 factors is equal to 5 by 6. Next one. A die is thrown once. Find the probability of getting at most Find the probability of getting at most 2. Okay. So, at most 2 means maximum we need to get 2. At most 2 means maximum we need to get 2. Okay. So, in those numbers, the number which is less than or equal to 2 we need to take. Okay, we have only 2 possible outcomes, that is 1 and 2. The outcomes favorable to at most 2 are 1 and 2. Therefore, the probability of getting at most 2 is equal to 2 by 6 is equal to 1 by 3. 2 by 6, that is equal to 1 by 3. Now, next question. 2 coins are tossed simultaneously. Find the probability of getting at least 1 head. 2 coins are tossed simultaneously. So the outcomes corresponding to 1 coin, that is H and T, and for the second coin, that is also H and T. Now we are going to toss 2 coins simultaneously. We are going to toss 2 coins simultaneously. Then the outcome in that case is HH, HT, TH and TT. Okay, this is our outcome in that case. Now we need to get the probability of getting at least 1 head. The probability of getting at least 1 head. Okay, at least 1 head means minimum 1 head we need to get. Here we have 2 heads, so that is possible. 1 head, 1 head. Okay, minimum we need to get 1 head. If you have 2 heads, that is not a problem. At least 1 head means minimum 1 head should be there. Okay, so the favorable outcomes, that is 3, and the total number of outcomes is 4. So the probability in that case is 3 by 4. Next question. Cards marked with the numbers 5 to 75 are placed in a box and mixed thoroughly. 1 card is drawn from the box. Find the probability that the number on the card is even. The cards marked with the numbers 5 to 75. Okay, we have the cards marked with numbers 5 to 75. That means we have the cards with numbers 5, 6, 7, etc. 75. Then can you please tell me total how many cards will be there? Total how many cards will be there? Okay, the total number of cards, that is actually 75 minus 4. The total cards is actually 75 minus 4, that is equal to 71. Okay, the total cards is actually 75 minus 4 because we are excluding 1, 2, 3, 4. Those 4 cards we are excluding. Okay, the 4 cards we are excluding. We are taking the cards from 5 to 75. Okay, so the total number of cards, usually what you will do is you will try to find out the total number of cards by 75 minus 5. That is wrong because we are excluding only first 4 cards. We are excluding only first 4 cards. From 5 onwards we are taking the cards. Okay, so the total cards is 75 minus 4. Thus 4 because we are excluding only the first 4 cards. Okay, so the total number of cards we will get it as 71. The number of even cards. Okay, the number of even cards in that is equal to, even cards is equal to 35. Even cards is equal to 35. Then the probability of getting even number, even cards means card with even number, that is even cards. So the probability of getting even number is equal to 35 divided by 71. The probability of getting even number is equal to 35 divided by 71. Next question. A pair of dice is thrown once. Find the probability of getting an even number on the first die. 2 dice we are going to throw. Here we are going to throw 2 dice. Then the total number of outcomes. The total number of outcomes is 6 into 6. 6 outcomes for the first die and the 6 outcome for the second die. So the total number of outcomes is equal to 36. Okay. Now we need to find out the probability of getting an even number on the first day. Probability of getting an even number on the first die. Okay. So the even, we know that the sample space corresponding to the die throwing experiment is 1, 2, 3, 4, 5, 6. The sample space corresponding to the die throwing experiment is 1, 2, 3, 4, 5, 6. In thus the even numbers 2, 4, 6. Okay, even numbers 2, 4, 6. Okay, so we need to get the even number on the first die. So either we need to get 2 in the first die, or we need to get 4 in the first die, or we need to get 6 in the first die. Now how many odd pairs we will get such that the first position either 2 should be there, or 4 should be there, or 6 should be there. Okay, we can write the combinations like 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, right? We will get this much of ordered pairs starts with 2. Similarly, we can write the ordered pair which starts with the 4, like 4, 1, 4, 2, 4, 3, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So the total number of favorable outcomes, is equal to 18. So the probability is equal to 18 by 36 is equal to 1 by 2. 18 by 36 is equal to 1 by 2. Next question. A die is thrown once. Find the probability of getting a number which is either a multiple of 2 or multiple of 3. Die is thrown once. We have only one die. The outcomes in that case is 1, 2, 3, 4, 5, 6. Right. we need to take the numbers which is multiple of either the multiple of 2 or the multiple of 3. Either the multiple of 2 or the multiple of 3 we need to consider. So 2 is a multiple of 1 we can't take because it is not a multiple of 2 or 3. 2 that is a multiple of 2, so we can consider this. 3 that is a multiple of 3, so we can consider that. Now 4 that is a multiple of 2, so we can consider this. 5 that is not a multiple of 2 or 3, so we can't consider that. 6 that is multiple of 2 and 3, that is not a problem. Either the multiple of 2 or the multiple of 3. Okay, so we can consider 6 also because that is a multiple of 2 or it is a multiple of 3. So the favorable outcomes here it is 4 and the total number of outcomes that is 6. So 4 by 6 is equal to 2 by 3. 4 by 6 is equal to 2 by 3. Next question. A die is thrown once. Find the probability of getting a number which is not a factor of 36. 36. This is our outcomes in the case of die throwing experiment. 36 factors. 1 is a factor. 2 is a factor. 3 is a factor. 4 is a factor. 6 is also a factor of 36. Okay. Here we need to find the probability of getting a number which is not a factor of 36. Which is not a factor of 36. So what is our choice? The favorable outcome, that is 5. 5 is not a factor of 36. So we have only one favorable outcome. So 1 by 6 is our probability. Next question. What is the probability of non-occurrence of an event which is certain to happen? Non-occurrence, which means impossible event. Okay, non-occurrence means impossible event. The question is, what is the probability of non-occurrence of an event that is certain to happen? Okay, so non-occurrence means it is an impossible event. Non-occurrence means impossible event. Impossible event, the probability that is 0. A probability of an impossible event that is 0. Now, next question. What is the sum of probabilities of all the elementary events of an experiment? What is the sum of probabilities of all the elementary events of an experiment? Okay. The sum of probabilities of all the elementary events of an experiment is always 1. The sum of probabilities is equal to 1. So the sum of probabilities of all the elementary events is 1. The probability of getting an impossible event is 0. The probability of getting a sure event, that is 1. Now next question. The probability of selecting a rotten apple randomly from a heap of 900 apples is 0.18. Okay. The probability of selecting one rotten apple is equal to 0.18 from a heap of 900 apples. What is the number of rotten apples in the heap? What is the number of rotten apples in the heap? Okay, the probability of selecting one rotten apple is equal to probability of selecting a rotten apple. Probability of selecting a rotten apple, that is equal to 0.18, and the total number of apple it is given, that is 900. Total number of apple that is given, that is 900. So the probability is given and the total number of outcomes is also given. Now we need to find out the number of outcomes favorable to or even, which means we need to find out the number of rotten apple. We need to find out the number of rotten apples. That is, the probability of getting a rotten apple is equal to number of rotten apple divided by total number of apple, right? Divided by total number of apple. That is equal to number of rotten apple, we don't know. So number of rotten apple divided by the total number of apple is given, that is 900, and this probability is also given, that is 0.18. Okay, so 0.18 is equal to number of rotten apple divided by 900. Then what is number of rotten apple? Number of rotten apple is equal to 0.18 into 900. 0.18 into 900, that is equal to 162. 0.18 into 900, that is equal to 162. Next question. A pair of dice is thrown once. What is the probability of getting a doublet of odd number? A pair of dice is thrown once. Okay, that means we are going to throw 2 dice at a time. So obviously we will have ordered pairs as outcomes. So here we need to find out the probability of getting a doublet of odd number. Doublets means 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. Okay. Doublet means the first entry and the second entry, that should be same. The first entry equal to the second entry, then that ordered pair is called doublet. Okay, this is we have 6 doublets in the case of throwing a die 2 times, throwing 2 dice simultaneously. Okay, in this we need to take the doublet of odd number. Okay, this is doublet of odd number, this is doublet of odd number, and 5 5, that is also the doublet of odd number. So what is our probability? Total in the case of throwing a die 2 times or throwing a pair of dice, the total number of outcomes is equal to 36, and we have 3 doublets of odd numbers. So the probability is 3 by 36 is equal to 1 by 12. 3 by 36 is equal to 1 by 12. Next question. Deepika has a die whose 6 faces show the numbers. 6 faces show the numbers 1 1 1, 2 5 7. Find the probability of getting number 1 if the die is thrown once. Okay, we need total how many outcomes are there? 1 2 3 4 5 6. Total number of outcomes 6. We need to get 1. How many ones we have? We have 3 ones. So the favorable outcomes is equal to 3. So the probability equal to 3 by 6, that is equal to 1 by 2. The probability equal to 3 by 6, and that is equal to 1 by 2. Now 3 mark questions. A pair of die is thrown once. What is the probability of getting the number 4 on one die at least? 4 on one die at least. Okay. The total number of outcomes in the case of pair of die is thrown once. The total number of outcomes 6 into 6 is equal to 36. And here we need to consider the ordered pairs which has at least in the first position or in the second position 4 should be there. Okay, so we will write the ordered pairs. 4 1, 4 2, 4 3, 4 4. At least means minimum. If you have two entries are 4, that is not a problem. 4 4, 4 5, 4 6. Now 1 4, 2 4, 3 4, 5 4, 6 4. Okay. Total how many outcomes are there? 1 2 3 4 5 6 7 8 9 10 11. So the total number of favorable outcomes is equal to 11 divided by 36. Okay, that is the probability of getting the number 4 on one die at least. Now next question. A letter is chosen at random from the letters of the message, "Hey dude, what's up?" HEYDUDEWASS. HaydudeWASS. What is the probability that the chosen letter is a consonant? Okay, chosen letter is a constant. The total number of outcomes. How many letters we have? The total number of outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the total number of outcomes total is equal to 13. Now we need to find out the consonants. That is H, Y, D, D, W, S, S, P. Total 8 consonants we have in that word, in that message HEYDUDEWASS. Okay, so the probability is 8 by 13. Probability is 8 by 13. Okay, now next question. Chances of winning a game are 60%. Chances of winning a game are 60%. 60%. If Anil has played the game 20 times, Anil has played the game 20 times, how many times he can expect to lose? How many times he can expect to lose? This is the chance of winning the game. Then the chance of losing the game is equal to total 100% minus 60% is equal to 40%. 100% minus 60% is equal to 40%. And the Anil played the game 20 times. Then the probability of losing the game is equal to 20 into 40%. That is equal to 20 into 40 by 100 is equal to 8. We will get, that means in 8 games there is a possibility to lose. Okay, the chance of losing the 8 games, we have the chance of losing. Next one. One card is drawn at random from a well shuffled pack of 52 cards. Find the probability of drawing neither an ace nor a king. Neither an ace nor a king. The total number of cards, that is equal to 52. The total number of cards is equal to 52. Total number of cards is equal to 52. Now, neither an ace nor a king. Total number of ace is equal to 4 and total number of king, that is also equal to 4. So, neither an ace and nor a king means we can't take ace or king. We can't. So, the favorable outcomes is equal to what? The favorable outcomes is equal to 52 minus the number of ace minus number of king. That is equal to 44. So the probability is equal to 44 divided by 52 is equal to 11 by 13. Next one, a non-spade. Okay, the total number of spade is equal to 13. Total number of spade is equal to 13. Non-spade means we can take the cards. Non-spade is equal to 52 minus 13 is equal to 39. So the probability is equal to 39 by 52 is equal to 3 by 4. That is equal to 3 by 4. Next one, a queen of black. A queen of black. Okay, we have 2 sets of black cards. Then the number of black queen is equal to 2. Then the probability is equal to 2 by 52. That is equal to 1 by 26. 2 by 52, that is equal to 1 by 26. Next question. Find the probability that a non-leap year chosen at random has first one 52 Sundays. 52 Sundays, and second one 53 Sundays. 52 Sundays and 53 Sundays. Okay, so we know that the total number of days in a non-leap year, total number of days in a non-leap year, is equal to 365. Okay, the total number of days in a non-leap year is equal to 365. That is actually 52 weeks, complete weeks plus 1 day. 52 weeks plus 1 day. Okay, the first question, we need to get 52 Sundays. In those 52 complete weeks, we have 52 Sunday. And this 1 day extra we have, then that 1 day, okay, that 1 day, that should be either Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, that cannot be a Sunday because we need to get 52 Sunday. If it is Sunday, then we will have 53 Sundays. Okay, that 1 extra day, if it is Sunday, okay, 7 possibility for this 1 extra day. Okay, 7 possibility, that 1 extra day, that either that may be Sunday or Monday or Tuesday, Wednesday, Thursday, Friday or Saturday. Right. So we have 7 possibility for this 1 extra day. If it is Sunday, that 1 extra day, if it is Sunday, total now we have 52 Sundays plus this extra Sunday, that become 53 Sundays. But here we need to get 52 Sunday only. That means that day can be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So the total number of favorable outcomes is equal to 6. And the total number of outcomes is equal to 6 by 7. If you want to get 52 Sundays, then the probability is 6 by 7. Alright. Now, the second one is 53 Sunday. The 53 Sunday means from those 7 days, that 1 extra day, that should be Sunday. Okay, that should be Sunday. Then only we will get 53 Sundays. Already we have 52 Sundays and 1 extra day. And that 1 extra day, that may be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. In that, we should get, if you want to get 53 Sunday, that 1 extra day, that should be Sunday. Then only we will get 53 Sunday. So in that case, the favorable outcomes is 1 and the total number of outcomes is 1 by 7. So this is 6 by 7 and the second one is 1 by 7. In a non-leap year, we have 365 days. 365 days means 52 complete week and 1 extra day. 52 complete week means we will have 52 Sundays, 52 Mondays, 52 Tuesdays, similarly 52 Saturdays. Now we need to get 52 Sunday means that extra day, that cannot be Sunday. That can be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So favorable outcome 6 by 7. And 53 Sunday means that extra day should be Sunday. So we have only one favorable outcome, that is Sunday. So the probability is 1 by 7.